Friday morning to you geometry students. Hope you guys are doing well. Friday is always the best day of the week for you guys, I'm sure. Another week done, and seniors 1 week closer to graduation. So congratulations to you guys. Let's keep working hard. Hope you did well on your quiz today. I should have those graded and back to you on Monday. I felt like it was an easy to moderate quiz, and the test will definitely be much more difficult than the quiz was. But I hope you did well. I hope you studied all of your fill-in-the-blank types of questions, and I hope you did well on the math problems. Some announcements real quick, students. First of all, you have a test next week. It will be on Friday as far as I know. So you will be given a review sheet on Thursday. You do owe me homework from yesterday, so would you please turn that in? Make sure your name is on it. Make sure that you get that turned in, please. And then next week's schedule on Monday, I'm trying to go a little easy on you guys. I'm not going to give you any homework over the weekend, which usually I do, but no homework over the weekend. So when you come into class on Monday, there'll be no notes to take. You're just going to work on homework Monday in class. So I'm giving you an easy weekend and a semi-easy Monday. And then Tuesday and Wednesday, we'll hit it hard for 2 lessons. And we might have a little bit of notes left over on Thursday. We'll see how that goes. Then Thursday will also be a review sheet, and Friday will be your test. So please work hard, please finish well, and after next week we'll have 2 weeks under our belt, so that's good. All right, here we go. As always, I go fast. You guys know that, and pause or rewind the video if you need to. If it took you longer than usual to take the quiz and you don't get this video finished, it is your job to watch it over the weekend. You must watch it over the weekend and get your notes taken, okay? All right, we're looking today at a topic called vertical angles and linear pairs. Vertical angles and linear pairs, and the lesson number is 2.4. And if you keep track of the date, which I encourage you to do, today is the 6th, September 6th, 2013. Now, you don't need to write this down, just listen. You need to know what vertical angles are, and usually I give you guys a definition, you know that. But today I'm not concerned with you learning a definition so much as just getting the concept as to what vertical angles are. So I want you to go ahead and take some notes, not on this right here, but on what I'm going to show you right now. So go ahead and write this down, please. All right, let's say we have a line like this. Go ahead and put that in your notes. And a line like this, okay? Now, let's go ahead and call this right here angle 1. Let's call this angle 2. Let's call this angle 3. And let's call this angle 4. All right? Instead of giving you a definition, I just want to teach you what vertical angles are. Angles 2 and 4 are vertical angles. So vertical angles are angles when 2 lines intersect that are across from each other. Angles 1 and 2 would not be vertical angles. Angles 2 and 3 would not be vertical angles. Angles 4 and 3 would not be vertical angles. Angles 1 and 4 would not be vertical angles. Angles 2 and 4 would be vertical angles, and also angles 1 and 3 would be vertical angles, okay? And that's a little easier in this case. I'm big on definitions, you guys know that, but in this case here, that's a little easier, just giving you a picture of what vertical angles are. Let's also talk about linear pairs for a second. I'm not concerned with the definition like I usually am, but I want to give you a picture of what we're looking at, so please take some really good notes on this picture. Whenever you have a straight line, okay, and then you have coming off of that line another line. It can be in any direction, it doesn't matter, okay? Anytime that happens, do you not have 2 angles? We'll call these angles 5 and 6. Do you not have 2 angles? Well, sure you do, definitely. Those 2 angles are called linear pairs. And by the way, let's take this a step further. If this line, and pretend that was one line. I know you can see where it's kind of broken there. Let me put a point there so it looks like one straight line going through. And by the way, if you had 2 lines intersecting like this, then you definitely could say that 5 and 7 are linear pairs. 7 and 8 are linear pairs. 6 and 8 are linear pairs. 5 and 6 are linear pairs. Now think of what you learned a couple days ago. 5 and 6 are also called what else? Adjacent angles. Don't forget that. Oh, so all adjacent angles are linear pairs. No, not at all. those two angles right there are adjacent angles. We'll call it angles 1 and angle 2. Angles 1 and angles 1 and 2 are adjacent because they share a vertex and they share a common side. So here's an example of adjacent angles that are not a linear pair. But here's an example right here. Angles 5 and 6 are linear pairs. How do I know that? Because I have a straight line. See that straight line right here? And I have one line coming off of it like that. Do you see that? So 5 and 6 are linear pairs. They're also adjacent angles. They're both, okay? And that's possible. So 5 and 6 are linear pairs, 6 and 8 are linear pairs, 7 and 8 are a linear pair, and 5 and 7 are a linear pair. Okay? So that's what linear pairs are. Now let's continue on. Let me grab a quick drink here. Now in your notes, there's no need for you to draw these pictures. Just write page 75, example 1. And I want us to label each diagram as either vertical angles or linear pair or neither. So let's start with letter A right here, this problem right here. Angles 1 and 2. Well, students, do I not have a straight line right here? Sure. Do I not have one line coming off of it? Sure. These two angles are side by side, so A is an example of a linear pair. Now let's take a look at 3 and 4. Be really, really careful here, okay? And by the way, I want to pause and tell you something. All the pictures today are going to be blurry. I tried something new with my camera and downloading these, and it didn't work, so I'm not going to do it again. I tried doing a video and pausing a video, and it didn't work. So just put up with it today, and then next week it'll be back to normal where the pictures are a lot clearer. But anyways, take a look at this here, angles 3 and 4. Notice how this line is bent. It hits here and then bends. What that means is we don't have two lines intersecting. We have one line here, and then one line here, and then a third line like this. Okay, you can't say, look at my blue marker here, you can't say that this is one line. It's not. It bends right there. So we do not have two lines that are intersecting. We do not. And so we can't say that 3 and 4 are vertical angles, nor can we say they're a linear pair. Now, if this line would have kept going straight like that, then we could say we have vertical angles, but that is not two straight lines intersecting. So we do not have we have neither. We do not have a linear pair or vertical angles. Now here, notice that we have good two solid straight lines intersecting like that, and 5 and 6 are across from each other, so these are vertical angles. All right, this is a postulate you need to know. You will be responsible for this, and this is so important, students. This is so important. If two angles form a linear pair, then they are always supplementary, always. So let's go back a page. See this linear pair right here? Angles 1 and 2, they're a linear pair. Well, guess what else they are? They're supplementary also. That means they add up to a 180. So if two angles form a linear pair, then they are supplementary. You do not need to draw this example I'm doing now unless you want to. I'm just giving you something to look at. We'll call this angle 1. We'll call this angle 2. Angles, and you do not have to write this down. It's up to you. Angles 1 and 2 are a linear pair. Also, angles 1 and 2 are what? We just learned it in the postulate. They're also supplementary. So if two angles form a linear pair, they are also supplementary. Always. You need to know that. Now let's go ahead with that in mind. Let's go ahead and you don't need to copy this diagram down unless you want to. You can just write page 76, example 2 in your notes. Notice we have a straight line here and a straight line here coming up. And I'm telling you this angle here is 62 degrees. I want you to find the measure of this angle here. Well, obviously we have a linear pair. We have a straight line with a line coming up. So if we have a linear pair, these two angles have to add up to 180. That's what our last postulate just said. If two angles form a linear pair, they are supplementary. So 180 minus 62 would be 118 degrees. And so this angle right here would have to be 118 degrees because 118 plus 62 gives you 180. All right, this is not in your book. This is for one bonus point, so go ahead and draw this in your notes. And by the way, again, please understand I'll have better pictures next time. I tried something new. It just didn't work. That's 107 degrees. All right, so go ahead and pause the video at this time for one bonus point. I want you to go ahead and find this angle right here with a question mark. What would the measurement of that angle be? Okay, hopefully you did well on this problem. Because we have a linear pair, we have a straight line like this with a line coming off of it. We have a linear pair. We know that linear pairs are always supplementary, postulate 7. And so because of that, these two angles have to add up to 180. And so 180 minus 107 would be 73 degrees. And so the answer for one bonus point is 73 degrees. All right. Theorem 2-3, you're responsible for this. This is so important. Vertical angles are congruent. So let's think about what we've learned so far. We've learned what linear pairs are, and linear pairs are always what? Supplementary. We've learned what vertical angles are, and now we just learned that vertical angles are always what? Congruent. Now, you do not have to draw this diagram unless you want to. Totally up to you. If you understand it, you just want to watch, that's fine. We'll call this 1, 2, 3, and 4. Angles 2 and 4 are congruent. I know that because they're vertical angles. Angle 1 is congruent to angle 3. I know that because they're vertical angles. By the way, 2 and 3 are a linear pair, so angles 2 and 3 are supplementary. Angles 3 and 4 are supplementary. Angles 1 and 4 are supplementary. And angles 1 and 2 are supplementary. Vertical angles are congruent. Now, you do not need to take notes on what I'm about ready to do, but please don't tune me out and daydream. I want you to listen and pay attention, okay? Let's do an informal proof. Now, you've probably heard the word proof before from your fellow students. It's a really dreaded word in geometry, and we're going to be doing proofs this year, and they're really difficult. But for right now, I'm just going to kind of show you the general, just a general informal proof. I want to prove to you how we know that vertical angles are congruent. So just kind of watch and see if this makes sense, okay? I'm going to call this angle 1, angle 2, angle 3, angle 4. All right, first of all, I'm going to move this up and get a little more room, so thanks for your patience. Hold on one second, please. All right, very good. All right, I would like to prove, let's use vertical angles 1 and 3. I want to prove that angle 1 is congruent to angle 3, okay? I would like to prove that. So now think about this for a second. I'm going to first of all state that angles 1 and 2 and angles 2 and 3 are linear pairs. And my reason for that would be definition of a linear pair, right? I taught you what the definition of a linear pair is. So my reason over here would be definition of a linear pair. Now again, just watch. You don't have to write this down. Just watch and listen. I can state that angles 1 and 2 and angles 2 and 3 are linear pairs because definition of linear pairs. Well, then I can state that angles 1 and 2 and angles 2 and 3 are what? Supplementary. And how can I state that? Postulate 7. Remember postulate 7? Let's go back to it here. Postulate 7. If two angles are a linear pair, then they're supplementary. So I stated these two sets are linear pairs. Now I can state they're supplementary. Now, if they're supplementary, look at this. I can now state, are you ready? This is really, really crazy, but watch this. I can now state that angle 1 is congruent to angle 2. Or excuse me, angle 1 is congruent to angle 3. How in the world can you state that, Mr. Earhart? Okay, well, I'm glad you asked, and think about it for a second. A day or two ago, we learned a postulate or theorem. I forget what it was. I think it was yesterday we learned this. Remember what it said? It said, if this is so cool, listen, if two angles are supplementary to the same angle, then those two angles are congruent. We learned that yesterday. Look back in your notes if you want to. If two angles, and now you're seeing why it's so important to learn all this stuff as we go. If two angles are supplementary to the same angle, then they're congruent. So look, angle 1 is supplementary to 2. Angle 3 is supplementary to 2. So angles 1 and 3 are supplementary to the same angle, angle 2. So if two angles, angles 1 and 3, are supplementary to the same angle, angle 2, then those two angles are congruent. So there we go. I forget what I would put here. I guess I could quickly, I don't want to take a lot of class time. I guess I could quickly try to see if it'll pop up here. There it is right there. Theorem 2.2 from yesterday's notes. Theorem 2.2. If two angles are supplementary to the same angle, then they are congruent. Now, hold on one second, please. And the reason I wanted to look that up was for the reason over here, I forgot the number, it would be Theorem 2.2. And that's poor teaching. I apologize for not having that, but there we go, Theorem 2.2. Okay, that's an informal proof. We're going to do more of those as the year goes on. You'll be doing those on your own. They're difficult, but we will be working on those. Okay, here we go. I would not worry about drawing this diagram. Just write down page 76, example 3 in your notes. And here we go. This angle right here is 50 degrees. I want you to find the measure of angle CED. Here's C to E to D. So a question mark right here. Well, those are vertical angles, right? What do we know about vertical angles? They're congruent. So the measure of angle CED has to be 50 degrees. Vertical angles are congruent. All right, let's try another one. This one's not in your book. This is for one bonus point. Before you start to work on it, again, it was all blurry, so I had to write here. You want to find the measure of HJK, so this angle right here, and this angle here is 115 degrees. So go ahead and pause the video. You probably don't even need to pause the video, to be honest, but pause the video, write down what your answer would be, what the measure of this angle is, and turn it back on and see if you got it right. Okay, hopefully you did well on this. Obviously, these two angles right here are vertical angles, and vertical angles are congruent. So the answer to the missing angle, where there's a question mark right there, the answer is 115 degrees. Okay, moving on to page 77, example 4. You don't need to copy this diagram unless you want to. Just write this in your notes. Page 77, example 4. Now I have two lines that are intersecting, and in case you can't read it, this angle right here is 35 degrees. Now, if I know one angle out of these four when two lines are intersecting, students, you should be able to find all of these just like that, no problem. First of all, this angle here with a dot and this angle here, they're vertical angles. So if this is 35, then angle 2 also has to be 35 degrees. You should see that pretty well. And now this angle right here and this angle right here, they're a linear pair. See this straight line right here? You see that? See how this line's coming off of it right here? So this angle here and this angle here are linear pairs. Well, we know that linear pairs are supplementary. So all that I have to do to find the measure of angle 1 is to take 180 degrees and subtract 35, and I will get 145 degrees. So now I know the measure of angle 1 is 145 degrees. So 145, and hold it. Aren't these two vertical angles right here? Sure they are. They're right across from each other. Two lines intersecting right across, so angle 3 also has to be 145 degrees. I hope that made sense. That's pretty easy to do. I mean, vertical angles are congruent and linear pairs are supplementary. Now let's go ahead and try another one here. Not for a bonus point, we're just going to work it together, okay? And this is page 77, number 1, in the middle of the page, if you want to write that down. Page 77, number 1, in the middle of the page. Well, let's see. Obviously, this is 28 degrees. If you can't read that, it's 28 degrees. These two are vertical, so I know right off the bat the measure of angle 2 is 28 degrees, okay? That's pretty obvious. And then look, this angle right here with one dot and this angle here with one dot, they're a linear pair, right? Here's a straight line, and here's a line coming off of it. So these two angles here, this angle and this angle, are linear pairs. So to find the measure of angle 3, I just have to take 180 degrees and subtract 28. All right? And that would be 152 degrees. So now I know this angle right here is 152 degrees, and that would be the measure of angle 3. And then vertical angles are congruent. So this angle right here has to be the same as this. So the measure of angle 1 equals 152 degrees. All right, pretty easy, not too bad. All right, let's take a look at some algebra now. Let's apply some algebra to geometry. This is 4y minus 42. This is 2y. I want you to solve for y. Notice how this angle here with one dot and this angle here, they're vertical angles, and vertical angles are congruent. So if they're congruent, I can state that 4y minus 42 equals 2y. I'm going to bring the 4y over and make it a negative 4y. When I do that, the positive 4y is gone, and I'm left with negative 42 equals negative 2y. Divide both sides by negative 2. A negative divided by a negative is a positive, and y equals 21. Not too bad. All right, that was page 77, example 5, if you want to write that in your notes so you know where the problem came from. All right, and now be careful on this one. Watch carefully. Notice this angle here with one dot and this angle here. They're not vertical, they're linear pairs. I've got a straight line here with a line coming off of it. And we know that linear pairs are supplementary. Please don't take these two angles and set them equal to each other. Nowhere have I taught you that linear pairs are congruent. I have taught you that linear pairs are supplementary. That means if you take your one angle, 20t plus 5, and add the other angle to it, 15t, added together they should equal what? 180. That's what I've taught you. So we can simplify the left side. We have we have a t term and a t term, so 20 plus 15 is 35t plus 5 equals 180. And now we're going to bring the 5 over and make it a negative 5. And so when I do that, the positive 5 is gone. And I'm left with 35t equals 175. Now divide both sides by 35, excuse me, and I think the answer is 5. Let's see, 25, yes, the answer would be 5. So t equals 5. So you have to know when to set the two angles congruent to each other, and you have to know when to add them together and set them equal to 180, okay? Vertical angles are congruent, linear pairs are supplementary. Now, students, have a great weekend, no homework, so enjoy that, and on Monday we'll come in, we'll work some homework problems on these notes. Have a good weekend.